Hello everyone, my name is Arkapura Mahata, register number UR15C051. Today I am going to demonstrate my 7th system software and case tool lab experiment, which is predictive parser. So in predictive parser, we see the code first. Here we have declared a util package to use scanner mostly. Then we have declared a main function in which we have two scanner objects S and S1. We have two integer variables tno and ntno, two string arrays t and nt of size 10 each, and then we ask the user to enter the number of terminals which is stored in tno, and then the number of non-terminals which is stored in ntno. And the list of terminals is stored on t of I, and list of non-terminals in nt of I. So now we then we in the start a for loop where we initialize in p of t equal to null in everything. Then you ask the user to enter the parse table, and the parse table entry is done using two for loops, and it is taken in pt of ith jth position every time. And then we display the parse table using two for loops also the value of it by at tno and the ntno length value. Then we have two a character ch variable and a flag variable integer type, a character variable temp, then pws, c and stack, three string type variables. Then in a do while loop we initialize flag to 0, stack to $s, and print the string to be parsed, and string it is taken in ip. Then ip is concatenated with $sign. In that while ip not equal to $, we initialize c to null, pws to null, and print stack and also ip. Then we initialize temp to ip dot character at 0, and we concatenate c with t. Now initialize to stack dot char at stack of length -1. Then pws is initialized by pws concatenate with temp. Stack is assigned to stack dot substring of 0 to stack of length -1. And now we check if c equals to pws, we print a new line, and also we take the substring of ip from 1 to its length and then continue. Then we have two integer values xc and xr, which is initialized to 0 initially. And then we check if array dot as list of nt contains pws, xr equal to arrays dot as list of nt at the index position of pws. Else we flag is initialized to 1 and we break it. If arrays dot as list contains c, then xc is initialized to array dot as list index of c. S flag is initialized to 1 and then we break. Then we initialize string of alt which is initialized to pt of xr and xc position. Then we print pws produces alt, and if alt equals to @ we continue. Then we get the reverse of the string using new string buffer alt dot reverse and converted it to string, and we concatenate the stack with reverse. And then we print stack, then ip also, and we check if flag is equal to 0, and if ip equals to $, and stack dot equals $, we print the string is accepted, else the string is not accepted, and also it is an invalid table provided by the user. And then if we want to continue to check for any other string, we take an input from the user and we keep on doing it while it is equal to 1. So now for the convenience, I already have a given output where we enter the number of terminals as 4 and the number of non-terminals as 5. The list of terminals is q, a, b and $, list of non-terminals s, a, b, c, d, and accordingly we enter the parsing table. S of q is initialized to q, a, b, c, a of a is a, and a of b is b, b, d, b of a is a, b of b is $, b of $, is a, and c of b is b, and c of $, is at the rate, d of a is at the rate, d of b is at the rate, and d of $, is at the rate, and hence the parsing table is displayed as such. Then we enter the string which is to be parsed. It is q, b, b, a, b. As you can see, the predictive parsing is done here, and according to the parsing table, the string gets accepted, and then if asked to check for any other string, I gave 2 because I don't want to continue. So as you can see, the program is working perfectly. Thanks for watching this video. This will be the end of it.